All right, today we're going to do the demonstration magnesium burning in carbon dioxide. And we have the carbon dioxide here in the cooler, and we're going to pull it out there, and then we will put the magnesium on the surface and ignite it. So let me slip some gloves on because of the size of the magnesium or the carbon dioxide. I have to grab it and so you can see we've got a cube there, and what we've done is purposely cut the cube in half, or roughly in half, and then inside here is a divot in which we're going to put the magnesium, and then we're going to encase it so that the magnesium is pretty well isolated from the oxygen that's in the atmosphere here, and yet you will see that it continues to burn and doesn't go out because of lack of oxygen, but it goes out because we completely consume the magnesium. Now it has to be balanced out in that when we put the magnesium into the dry ice, we need to get it to ignition point, which is about 2,000 degrees. If we leave it laying there too long, then it's going to get so chilled that it's hard to light. So we have to put it in there, get flame to it, and then get the combustion reaction going. So we get the magnesium out there, move it over a little more to the center, and then we apply the heat to it. Once it catches fire, then we seal it, and then we can kill the lights. And you see that it glows very brilliantly and it illuminates the cube of dry ice, but then it goes out, and the reason is we've used up all the magnesium. So let's bring up the lights. And what do we have left? Well, we've got some white material here on the surface, but you can see once we put a little pressure on it to get it to fall out of there, there is white there, which is going to be the manganese oxide that we produced here from those being combusted together. But observe when we push that down, we got this very black material, which, where did that come from? A silver metal, white solid here, cold, combustion reaction. The answer to that is from our chemical reaction, it is elemental carbon. And so a very brilliant transition between the reactants and what the products are. Very straightforward chemical reaction. The magnesium is one of those components sometimes used in fireworks that gives us the bright white spark. We have scaled this up because of the size rooms we do it in, and because the bigger the chunk of dry ice, the more it's glowing, a glowing orb. You really can do it in a fairly small amount and just reduce the smaller amount of magnesium in there. And it's more convincing when you've got a big chunk and all this dry ice around here that this is burning in spite of the carbon dioxide presence. And so you could scale it down. You can, again, the whole parameters of open flame and what you're doing. You can see sparks are flying out there, so you don't want any flammables around it. You want a non-flammable surface, and the natural normal safety distance is away. You can see it produces some smoke. We got the downdraft on over here that can pull that away, but it's a minimal amount of gas produced as a result of reaction. The other safety aspect that won't come to play, which we are purposely dealing with, is the volume of magnesium. The reality is those chemical companies and those producers that provide aluminum metals, magnesium metals, titanium, stuff like that, they're going to have a large volume stored around because they're producing it. If that catches fire, there's not a lot the fire department can do other than bring hot dogs and start cooking hot dogs. It gets so hot they can't get close. 2,000 degrees ignition temperature, and then it's going to go up from there. You throw water onto that temperature of fire, you're going to break the water down into hydrogen, oxygen, and the potential of then exploding the whole thing and now throwing flaming metal all over the place. So literally the way they deal with fires like that, oftentimes is just let them burn out. If they can get close enough with small particulate like sand or something like that, they'll dump that on. But oftentimes the flame's so hot to get the sand close, you're going to melt the tires off the vehicle you bring it in with. So most often they just have to pull back, perimeterize around, and keep people away until it burns itself out.